There is a specific coordinate in our cosmic neighborhood where humanity is strictly forbidden from ever treading. It is not distance preventing us, but the sheer lethality of the destination we know as Venus. Nothing lives there yet. Over half a century ago, the Soviet Union launched a relentless machine procession. Into that furnace went Venus, the inaugural human artifact, to successfully breach a dense, alien atmosphere. However, the true story of this massive undertaking remains deep within the annals of history. The Soviet Venus Initiative kicked off in 1961, merely 4 years following Sputnik's historic orbit. The prevailing scientific consensus suggested that those opaque clouds lay a tropical world similar to ours. The first tangible reality check arrived in October 1967, when Venus penetrated the sky. As Venera sank deeper, the situation deteriorated rapidly. 10 atmospheres crushed instantly into 20 atmospheres. The probe had been flattened and incinerated, while still kilometers high, never touching the dirt below it. The mandate was brutal because any machine targeting the Venusian ground needed like a deep submersible. They also supercooled the probe to -8 degrees Celsius, creating a thermal shield against the fire. Venera 7 entered and slammed into the rock at 17 meters per second, toppling the lander. A faint whisper of a signal had persisted after the crash had occurred. As the Venusian heat invaded the shell, salt melted slowly, absorbing the thermal energy to survive. Venera 9 beamed back, the first picture ever taken from a planetary surface in human history. It revealed a bleak, rocky world where sharp stones and volcanic layers littered the view for miles. When Venus 14 blew its lens, the metal disc landed precisely where the arm would strike. Instead of measuring the soil, probe measured the hardness of its own lens cap by mistake. The sky was a sickly yellow-orange colored by sulfur, scattering the light across the alien landscape. These missions provided more than snapshots. They offered ground truth from a hellscape that defies all imagination. The humidity sensors confirmed a containing dry world, less than 0.1% of total water vapor. Venera 15 and 16 mapped the north via rift valleys, suggesting massive tectonic stress loads. This was shocking because without water to grease the plates, Venus should not have active tectonic scars. Here is where the physics gets bizarre, because on the surface carbon dioxide stops acting like gas. Above 31 degrees it turns supercritical, becoming a fluid that is neither liquid nor quite gas. Technically, the surface is submerged in a supercritical where ocean, the air density rivals that of water. You could not swim in it, but this fluid moves heat so efficiently that temperatures remain identical. It acts as a planetary radiator, and some models suggest this fluid might have formed strange bubbles. The geological erosion we see might be from this supercritical fluid, carving the rock like water does. As a fellow hoodlum, eventually the insulation fails. So to stay longer, we need electronics that simply do not fear heat. Conventional silicon chips die at 300 degrees. But the solution is found in silicon carbide tech. This hybrid material has a wide band gap and can run efficiently at 500 degrees Celsius heat. NASA tested these chips in a Venus chamber for 60 days, and they ran flawlessly without issue. These chips are not supercomputers, but they are immortal enough to survive the crushing heat of Venus. Despite the date of Venus remains a riddle, because models say it had oceans billions of years ago. We do not know what triggered the greenhouse runaway, but radar hints at recent lava flows there. We do not know if the core is molten. And we do not understand the sulfur cycle. A strange nitrogen gradient suggests the crust is outgassing carbon dioxide, implying the planet is geologically alive. NASA plans to return with DAVINCI dropping a probe to taste the air in 2031. VERITAS will map the topography in high-resolution 3D, while Europe scans the interior for answers. The real leap is long-duration technology, like a rover that can drive for months on end. We could finally answer the fundamental question: is Venus dead, or is it still alive today? We must acknowledge the scrappy brilliance of the Soviet program, because they used scavenged parts, not labs. Early cameras actually used film salvaged from shot American spy planes meant for espionage purposes only. The pressure holes were hand-welded and seals used because gold resists sulfuric acid rot. Parachutes were tested in vacuums that could not match reality. Making it imprecise and highly dangerous work. Guessed and built and launched and succeeded, even though failures were common but hidden from view. Venus 13 used lubricants that did not exist to drill in 460 degrees. They did this without modern simulations, using raw engineering grit to survive the violent journey of descent. Hitting the upper air at 11 kilometers generated 11,000 degrees of pure friction heat. Then came the sulfuric acid smog clouds at 50 kilometers, where the probes found the biggest droplets. Below that, the oven begins. So at 30 kilometers, the parachutes were cut to speed the fall. The wind profile they mapped is paradoxical, with hurricane speeds up top, but barely a breeze below. In 1980, the Soviets launched Vega 1 and 2, which was a hybrid space mission. They dropped landers, but also French-designed helium balloons at 54 kilometers in altitude. For 46 hours, they rode super covering winds, half the planet and finding turbulence and lightning. This was a rare Cold War handshake, where East and West collaborated to explore the alien clouds. Now we must address the controversial topic of life, because scientists claim to see movement in photos. Experts quickly debunked the scorpion and disclaimed, proving they were just lens caps and digital artifacts. However, at 50 kilometers conditions are temperate, so some argue that microbes could float eating sulfur. In 2020, a team claimed to find phosphine gas, which is a massive potential biological signature. The data is heavily disputed and likely noise, but the door for life is not fully closed. Priorities shifted to Mars because Venus was expensive, so the expertise evaporated when Soviets fell. NASA focused on Mars because it looked colonizable, and we ignored the dead end Venus for decades. Only now, with exoplanet discoveries, do we realize Venus because most rocky planets resemble it. There is a haunting quality to those old grainy Soviet photos, showing a landscape humans cannot walk. It looks like a desert until you remember the crushing weight and burning air of that hell. Every rock in those blurry images is a warning, because Venus was once like Earth before breaking. Until we know why, our future remains uncertain, even though Venera is overshadowed by Apollo or Viking. But landing on Venus and working there for even 1 hour rivals any other space achievement. One day we might find them, but for now they wait in the silence and the heat.